Welcome back to our channel. Today, we're exploring the fascinating and complex world of autonomous weapon systems as detailed in our latest book. From the evolution of warfare technology to the ethical dilemmas of deploying AI in combat, we'll dive into how these systems are reshaping the battlefield. Join us as we unpack the challenges, drivers, and implications of AWS in modern warfare. Let's get started. To summarize the book in one sentence, you could say it's about the transformative impact of autonomous weapon systems on modern warfare, exploring their technological evolution, ethical dilemmas, and the challenges of integrating AI into military strategies. Across these chapters, we witness the rise of a future battlefield where intelligent machines may increasingly replace human soldiers. At the heart of this story is the concept of autonomous weapon systems, or AWS. These are tools that can identify, select, and engage targets without direct human control. While their potential seems endless, low-cost drones striking critical targets with fewer casualties, every chapter points to obstacles, risks, and ethical dilemmas that cast a long shadow over this technology. We begin with an overview of modern warfare's technological leaps. Once considered futuristic or purely speculative, autonomous systems are already appearing in conflicts worldwide. The drones used in regional wars illustrate the power of small, cheap, and effective weapons. The lines blur between conventional front lines and so-called safe zones, because drones can be easily modified to carry lethal payloads almost anywhere. This democratization of warfare, letting smaller groups access advanced weaponry, alters the balance of power and compels militaries to adapt quickly. To fully grasp these changes, we must consider context. Today's battles are more connected, more data-driven, and more automated than ever. Yet each operational environment is unique. Mountainous terrain, urban sprawl, remote deserts. We see how a system that works flawlessly in one setting might fail catastrophically in another. Additional uncertainty comes from the varied ways AWS could be deployed, from purely defensive roles like intercepting incoming threats to fully unsupervised missions where lethal force might be used autonomously. From there, we examine the drivers pushing armies toward automation. Political leaders often aspire to reduce casualties among their own troops, and robotic systems never tire or lose morale. Economic factors also matter. Mass-producing small autonomous devices can sometimes be cheaper than training and equipping large numbers of soldiers. And from an operational standpoint, removing human oversight potentially means faster reactions and fewer errors caused by fatigue or fear. On the flip side, these very benefits raise alarms. If humans aren't in the loop, how do we ensure control? Yet the path from human-operated weapons to fully autonomous ones is complex. In exploring deployment, we see the difference between simple automation, like a guided missile that follows a predefined path, and advanced autonomy, where machines interpret the environment and plan actions dynamically. Data from research institutes confirm that militaries around the world are investing in everything from targeting software to robotic logistics. But existing records can't capture the full scope. The distinction between partial autonomy, used mainly for tasks like navigation, and lethal autonomy, which decides life or death, is critical. Next come the obstacles. Even if it's technically possible to build a killer robot, ethical and legal frameworks might forbid its use. International laws of war demand proportionality and discrimination between combatants and civilians, tasks that can be challenging for algorithms. Human cognition and judgment are shaped by emotional intelligence, cultural understanding, and moral reasoning. So far, no machine can truly replicate that context. We then delve into wetware, the notion that replicating human-like intelligence involves bridging huge gaps in perception and decision-making. Human brains handle sensory-motor tasks so effortlessly that we rarely notice how complex they are. But for a machine, analyzing real-world inputs and responding appropriately can require massive computational resources. Even as AI advances in tasks like image recognition, the question remains whether we want to trust lethal force decisions to lines of code. Technical chapters reveal how reliant AWS are on layers of firmware, software, and hardware. Firmware, the invisible foundation enabling different parts of a system to cooperate, can accumulate technical debt if rushed or poorly designed. This debt shows up as fragile systems, quick hacks, or partial integrations that can break unpredictably. Similarly, software that must process real-time data faces the dilemma of how to interpret raw sensor information, especially on a chaotic battlefield. A glitch in the code or an outdated dataset might lead an autonomous weapon to misfire. Meanwhile, hardware constraints remain a limiting factor. Sensors can fail, power supplies can deplete, mechanical parts can jam, especially in extreme or dirty conditions where robots must operate without human intervention. As we move to oversight, we see that militaries thrive on discipline, trust, and leadership. Commanders must ensure weapons are used in line with strategic objectives and moral guidelines. Introducing fully autonomous systems disturbs that chain of command by removing real-time human choice. Some propose meaningful human control, requiring at least partial human authority over lethal decisions. But a central question persists. Can the complexities of battlefield decisions, normally guided by human experience, be encoded into software? And if not, how do we prevent tragedies that arise from a machine's misinterpretation? Finally, the conclusion reflects on how regulating these technologies has proven contentious. We recall earlier efforts to limit the use of certain weapons, like chemical agents, through international treaties. Achieving a global consensus on banning or limiting AWS is difficult because each nation weighs the strategic advantage of having them against the risk of rivals developing them first. Advocates of AWS argue that greater precision and faster response times could reduce collateral damage, while critics fear that once life-and-death authority transfers to algorithms, the potential for catastrophic mistakes grows. Either way, the chapters suggest that total prohibition seems unlikely. Progress will more likely come from partial frameworks, best practices, and ongoing debate in places like the Convention on certain conventional weapons. Yet the deeper message resonates. These autonomous systems aren't inevitable forces of nature. They arise from human choices, our engineering decisions, our strategies, our desire to protect soldiers or gain an edge. How we govern them will shape future battlefields. Will we keep humans in the loop, valuing empathy and moral judgment, or will we allow machines to decide lethal encounters alone? The outcome of this debate depends on diplomatic negotiations, public awareness, and the moral lines militaries refuse to cross. In short, technology can be harnessed or unleashed, but it's ultimately human judgment that steers warfare's future. Let's draw a conclusion for our book. In a world where technology and warfare are increasingly intertwined, this book serves as a crucial reminder of the importance of human oversight in the age of autonomous weapons. It challenges us to think critically about the future of combat and the ethical implications of removing human decision-making from the battlefield. As we close this chapter, let's not forget the power of stories to enlighten, challenge, and inspire us to think differently about the world around us. Until next time, take care and keep exploring the power of stories.